Now, I trust that you all have your graphing calculators because you're going to need them. Now, what we're going to be taking a look at here is dealing with graphical solutions of these linear equations. It's nothing that you have never dealt with before. You have always graphed out a line, given y and x, some kind of an equation. You've come up with points on it, put it on a chart, however you've wanted to deal with it. But it's nothing new. Nothing is different than what you've had to deal with in the past. Okay? For example, if you want to go and figure out what's going on, they give you this piece of information here. Y is equal to 0.55x minus 2.886. Now they say that this is a model for the data, for average sentence in months and average time served. So you put in the sentence, you figure out how much time is actually served based upon the formula. Okay? So just because you've been sentenced to 180 months doesn't actually mean you'll serve 180 months, according to what this says. Okay? Something goes in, something comes out. Now, if there is one thing in algebra that is of paramount importance, this, okay? If you can deal with this, algebra is a piece of cake, right? If you understand how to go and solve an equation. Now, number one there really isn't something that you've dealt a lot with, but it's extremely important because it simplifies things so greatly. I'll show you what I mean by that. I've got these algebraic equations here. Oh, come on, cooperate. And I want to go through and solve. Now, nothing is too drastically nasty there, right? But if you go and take a look at trying to simplify this and make it as easy as possible to deal with, we can go and fix this rather than trying to get common denominators and work with fractions. Sometimes fractions they're flat out ugly and we don't want to deal with it. But what we can do is this idea multiply through by a number. As long as whatever I do is done to both sides of the equation in the same way, we're okay. So what I would do is I'd multiply through by 12. What does that do for us? Well, if I were to take this term here, multiply it by 4, it'd cancel out, wouldn't it not? So this cancels out and this little whole thing here gets multiplied by 3, right? So that means that we end up with 3 times 2x minus 3 is equal to, everything must get multiplied by that 12. So over here, this 3 would cancel out and I'd get a 4, so I would just end up with 4x. Now that 1, there's nothing else there, so it just gets multiplied by 12. Now, if you take a look at what the original problem was and what I've changed it into, is that second step by far easier to deal with? Yeah. Distributed property and move things back and forth. By finding a value to multiply through by, clears the whole thing out and makes life a lot easier. So, if I were to take a look now at B, and I would want to go through and multiply a value through here, what would it be? Well, what does a 5, a 2, and a 20 go into? A 20. So if I were to multiply everything here through by a 20, 5 would go into there, that would cancel off, and I'd end up with a 4, so I would end up with a 4y. Does that make sense? I multiply here by a 20. Now, you'll notice that I've got two things here. Whenever we have a term, they're always going to be separated by addition and subtraction. So if I were to cancel off with this 2 here, that would bring this down to 10, correct? But I got another 2, so I could cancel that down, and it would go to a 5, right? Well, if you wanted to, could I go 2 times 2 is 4? 4 goes into 20 how many times? 5. So I just end up with minus 5y. Rather than trying to get a common denominator in here and then, yeah, don't worry about it. 20 gets multiplied over here, the 20 is completely gone and it's equal to 7. Is this a by far easier thing to deal with? Most definitely. Because when you take a look at what they gave you to begin with, that's just plumb ugly. Okay. Now, the next idea, if I'm supposed to go through, we're supposed to be solve if y is equal to that. Now, decimals, because the calculator usually deals with decimals nicely, I don't usually mess with it. But there is a way of dealing with this as well. If I were to go through and multiply everything by something, I can get rid of the decimals. Now, I take a look at this and I see that I got a slight problem. How many variables were in A? 1. How many variables were in B? 1. How many variables are in C? 2. Okay. Before I really continue on with this, I'm going to look at this a little bit closer and see if there's anything that I am given that would kind of get rid of this so I just have one variable. I'm told that y is equal to 0.72, yes? So does that mean that I could rewrite this as follows? 0.72 is going to be equal to 1.312x minus 2.56. Am I allowed to do that? By a substitution, correct? Now, I want to ditch these decimals. Personally, I just work with the decimals because I'm just going to drop them into the calculator. But if I wanted to get rid of this and drop it into whole numbers, what I could do is multiply through by a number. By a what? Nope. Close though. How many placed behind the decimal point here? 2. How many over here? 2. How many here? 3. Multiplied by 1,000. 3 zeros moves the decimal point over 3 places, so now I got 720 is equal to 1312x, okay, minus 2560. That's all it is. And again, you're dealing with whole numbers here, or I should say integers, and it's easy to deal with, right? But like I said, decimals would have been just as easy to deal with. Yes? You see something I goofed on? Because I have to move the decimal point over 3 places, 1, 2, 3. I got to add in that 0 behind it. Okay? Same thing over here, 1, 2, 3. Got to add in that 0 behind it. Okay? So that's why I did that. Because this one here went over 1, 2, 3. Okay? But that's an easy way of dealing with this. Okay? It's a simplification idea. So when we take a look at the steps that we need here on number 1, that solves it, okay, a lot quicker than having to deal with fractions. Okay? The rest of the steps there are just what we've been doing since Algebra 1. Okay? So, let's see here once. Okay? Now, if you got this equation here, is this easy to deal with? says it's hard for some people to pay off credit card debt in a reasonable period of time because of high interest rates. The interest rate paid on a $10,000 debt over 3 years is approximated by, and they give us an equation. Okay? When the interest rate is X percent, okay? What is the interest rate if the interest is $1,637.60? Well, we can go through and solve that, right? Because this value here is the output, what comes out of this. Okay? That would be our y. So you'll notice here that they went through and they solved it and they find out that the interest rate is very, very close to 10%. Okay? Now, rounding issues. This would probably continue on, 0.9998, we got that. If you were to round it to how many decimal places, how many should you? Out of curiosity. 2 or 3, depending upon the application. Because if I round this one to 3, or round this one at all, it's just going to kick it all the way up to 10, isn't it? Okay. But generally speaking, when we're dealing with this, you want 2 decimal places of accuracy. Some places, sometimes they want 3 decimal places of accuracy. I mean, if you're an engineer, you'd probably want 10 decimal places of accuracy for all you want, depending upon what the application is. But generally, for our purposes, 2 decimal places will be more than sufficient. Okay? Please do keep that in mind. Okay? So, stock market. It says, for a period of time, a man is very successful speculating on an internet stock, with his value growing to $100,000. However, if the stock drops rapidly until its value has been reduced by 40%, what percent increase will have to occur before the latest value returns to $100,000? Okay? So, how many think the quick and easy answer is 40%? Well, it dropped 40%, right? So should it not go back up 40%? In the last model, you guys were playing around with this idea of a percent of a number. Okay? And you kind of got the idea that if you take the same percentage for your starting amount and then your same percentage for the next amount, things were different, weren't they? Because it's always a percentage, same percentage, of a different number. Okay? So it's going to be different. So if I take 40% off of 100,000, by the way, what's 40% of 100,000? And yes, you should be able to do that just like that. Why? Because you're dealing with a 1. Okay? 100% of 100,000 is 100,000, right? 10% just move it over 1, 10,000. And 40% is 4 10,000s, right? Or 4 10%, I should say. So that's $40,000. So if it drops down 40%, we lost $40,000. Now we're at 60,000. But now I need the percentage of 60,000 to get me back up to 100,000. And if I'm at 60,000 and I need to add on 40,000 more to that, that's 2/3. Because if you think about 60, 20, 20, and 20, correct? So 2 20s add back on gets you up to 100%. So you may have lost 40%, but you have to have a 2/3 or a 66 2/3% increase in order to get back to where you were at again. Okay? Again, you've played with these things before. You've looked at and dealt with percentages. A lot of this comes down to just simply reading what it is asking and understanding. Understandings are a lot more difficult than what you expect. Okay? You can read it, but you got to be able to translate it into reality. Now, new concept for you. Zero of a function. Now, any number a for which f of a is equal to 0, it's called a zero of a function. Now, it says the three things are numerically the same. The x-intercept of a function is called a zero. Now, think about it here. If it goes through the x-axis, what is the value of y? 0. Okay? When we deal with equations, y is always the output. We put something in for x, we get something out for y. So when we have a function, f of x, if f of x is equal to 0, it's a function. Or I should say, it's going to be the 0 of the function. If I ask for real zeros, I look for real solutions for f of x equal to 0. These are all the same things. And we are going to spend an awful lot of time with this idea of trying to find the zeros, because we use the zeros to identify a solution to a specific question. That's how it goes. So, let's try this. It says for this function, I'm supposed to find what these are supposed to be. Now, you can easily go and calculate this out, but I highly recommend using the graphing calculator for this. You can use a spreadsheet. There are other ways of dealing with it. You can write it out by hand, but the graphing calculator is going to give you the best idea for what's going on here, simply because it gets you practice looking at different types of equations and graphs and seeing what's going on. So, y equals, I'm going to put in that equation of 13x minus 39. Now, do you know what kind of a graph that you are going to get with this? And you should know. This is in the form of a line. Y is equal to mx plus b. If x is just to the first exponent, first power, it's a line. I know this. You guys will eventually too. So if I graph this out, okay, I see this going on and I see just that. Now, what we generally like to see are the interesting things. Interesting things are maximums and minimums, crossing the axes. So, where does this thing cross the y-axis at? Oh, that's easy enough. Negative 39, right? Y is equal to mx plus b. B is the y-intercept. So what I would probably do here on the window is I would go and set my y minimum probably down to minus 50. Why? So that I can actually see what's all going on with it. Okay? So I got that, and I see all the nice, interesting things about this graph. So, I want to find f of 3. Trace button. What number should I put in? If I want to find f of 3, what should I have? I should see this as 3, right? So I hit trace, I hit 3, and I hit enter. And I get a nice 0. So, f of 3 is equal to 0. Okay? I want to know what the 0 of that is. Well, what's the 0 of this? 3. Not 0. 3. Why? Because if I put in x as 3 into this function, I get out 0. So, the x-intercept of this graph is going to be where? Now, do you got to list this as a coordinate? And the answer would be no. Because the question is, where are you going through the x-axis? We already know y is at 0. So to answer this question, it would end up being where? 3. Okay. What is the solution to 13x minus 39 is equal to 0? Guess what? 3. They're all the same thing. They all mean the same thing. They all represent the same thing. Okay? It's just different ways of stating the same question. So, let's try this. Now, we take a look at this with the trace button. And it's really handy. Whoops. However, do you always get nice whole number answers or integer answers? No, sometimes you get flat out wonky answers. You have no idea what to do with it. There is a way of figuring this out. The calculator will go and calculate out the zeros. Okay? You ask it for a zero, it'll find it. And not only that, they'll give you another little hint. When we are using answers, I realize that you guys love decimals because the calculator spits back decimals. But more often than not, the decimal that you get back is a rounded value. Okay? You can use the button on here, get the math, and then the fraction. It'll convert it into a fraction if it indeed is a rational number. And rational numbers are better than the decimal equivalent simply because they are accurate, okay, precise. So, now, we've looked at this problem here. We can multiply through by a 12 and we can do the solving on it. I'm going to show you some ways of dealing with this so that you can figure out where they are equal. Now, this is really just making the statement that this is equal to that, correct? So, one of the ways that we can do this is I'm going to clear this out and I'm going to put this on the left side. Okay? So, what I would do here is put in parentheses because I want the numerator first. 2x minus 3, close the parentheses, divided by 4. Okay? Now, I'm going to go down to the next line. Granted, you guys aren't going to have color, but you'll get the idea. This is going to be x, put it in parentheses, x divided by 3, and I tend to like using parentheses a little bit more with the graphing calculator when I'm putting things in, so I know that the calculator knows exactly what's going on. But sometimes it might get out of order. And this is supposed to be x over 3 plus 1. Okay? I am going to change my window back here so it's going back down to negative 10. And I am going to hit graph. Okay? So now, these two lines go across. Ooh, intersection. Intersection's out a little bit further, isn't it? So, window. I'm going to go out and move this out to say 20. Graph again. So I get to see a better picture of what's going on. Okay. So, where do these things intersect? I could sit here and try to figure that out. Trace, and push buttons. But what I want you to do, I want you to hit second, trace. And this is where we get all of these wonderful things. It'll allow you to calculate a value. It'll calculate a zero, calculate a min, a max, and an intersection. These two lines intersected, so guess what I want to look for? Number 5, the intersection. So I'm going to go down to 5, press enter. Okay? First curve, yep, enter. Second curve, yep, press enter. Guess. Just do that. So it says the intersection x is equal to 10.5 and 4.5. Okay? So when x is equal to 10.5, y is equal to 4.5. So we would say that the intersection is at where? 10.5, right? Okay. Now, what happens if I want to go and change this around and I want to look for the zeros? Okay. I'm going to put this equation in again. Now, since I am looking for this to be equal to 0, could I take what's over here and just slide it all over to the other side? So what you would see then would be something that would look like this. Now mind you, I haven't even begun trying to simplify this thing whatsoever. Is that legal? Yeah. Gets me my answer. Is it the easy way to do it? Maybe not, but we're going to put it in parentheses, whoops, x divided by 3, close it, plus 1 minus parenthesis 2x minus 3, close it, divided by 4. Okay? So all I did is I just took that 2x minus 3 over 4, moved it to the other side. Yes? Is that what it did? For those of you paying attention, following along, pretending you're interested. Now, I'm going to hit graph. Okay? Does it kind of, sort of, maybe look like this is going across the x-axis in about the same place as the other one was? Because remember, we were looking for where they were equal. Now we're looking for where it equals 0. Okay. Well, if it equals 0, wouldn't that mean that this is equal to that? That this subtract off the other piece was gone? So now I'm going to hit second, trace, so I'm into this. And what I want to find now is the 0. Okay? And now when I press enter, it's going to say, which line is this one on? If you take a look up here, it's not on the right line, is it? Arrow key down. If I hit the arrow key down, now it moves it to the red equation. Okay? If I arrow key down again, it moves it to the black equation. So you can use the up and down arrow keys to go and move around. Now, by the way, do you see the equation sitting up here? Is this the one that we wanted? So that's another way of verifying it, especially on yours. And it also says y3, another way to verify, because that's the third equation you put in. Now, it wants the left bound. What we need to do is put the little cursor on the left side of where we think the 0 is. So do I have it on the left side of where I think the 0 is? So I press enter. Now I want to go to the right of it. So I arrow key over, go to the right, and I press enter. So, is it crossing the y or the x-axis somewhere in between those two little lines there? Somewhere in that place. So I hit enter. And it says the 0 was at 10.5. So it gave us the exact same value that we expected. Because 10.5 allows this equation to be equal. When I set this thing equal to 0, 10.5 provides me from the zeros. Okay? So it gives me the exact same thing. Always the same thing. And just as a reminder, those of you in the studio audience, make sure that you're actually playing with the calculator as I'm going through this. Makes life easier for you. So, I've talked about solving the equation, finding a 0. Talking about the intersections. Okay? So, let's see. Now, they also talk about dropping this stuff into a spreadsheet. And for this type of activities, I always think a spreadsheet is going to be more trouble than it's worth. Is it doable? Yes. Will it do faster calculations? Yes. However, a spreadsheet doesn't automatically set up a domain like a graphing calculator does. It's originally dropping in your X and going from there. You have to do a little bit more work with it. Okay? Let's see. Now, last thing. There are going to be times when you are going to have to rewrite an equation in terms of other things. Now, if I look at this equation here for simple interest, it says that, grab this, go here, there, okay? So the formula for the future value and investment P's as simple interest R is that. Solve the formula for R. So we are going to use the exact same steps for solving any linear equation that we are here. I just want to end up with r. R is on one side, everything is on the other side. So, a p 1 plus r t. Okay. What would be the first thing to get rid of? Got to get rid of those parentheses out of there, so that means I could divide both sides by p. Is that legal? So what I have, a over p is now equal to 1 plus rt. That seem reasonable? Okay. You got to remember, the object of the game is to get at what's inside. You got to peel away the outside to get to the inside. Okay. So, what would you expect to do now? If I want r on one side and everything else on the other? Minus 1. Subtract the 1, subtract the 1. So now what we have is a over p minus 1 is equal to rt. How would I get rid of that t? Yeah, divide by t. Now, I got a wee bit of a problem here. I got a over p here as a fraction. So now we should really treat this in terms of a fraction. Okay? So instead of dividing by t, what should I multiply by? 1 over t. If I multiply both sides by the reciprocal, now I've got it set so that it would be 1 over t times a over p minus 1 is equal to r. Now, could I go distribute that out if I so chose? Yes, I could. But I'm not choosing to do that right now. Okay. But again, you're just peeling it away, trying to get at what's on the other side. Nothing any different than what you have done in the past. So, you can see they went and did that. They distributed it over here. Now, could I have identified the distributed property to begin with? Yeah. Subtracted p and divided both sides by pt? Yeah, I could do that. Does it matter? No. Algebraically, they are exactly the same. So, now, where this whole idea is extremely handy is problems like this, A and B. If I want to use the calculator, I need to have this thing set as a y equals, correct? So, can you go and change that A so that it's y equals? Do you know how to do that? If you take a look at B, do you know how to go and set that as y equals? Okay. It's just, subtract the x squared to both sides, divide by 4. Do you have to make it look pretty? No. Not at all. I mean, they go through here and do that. Could have I just left it as minus x squared plus 1, or, where am I at again? See, I could honestly just leave this one here as this. Wrong one. If all I am worried about is getting it into the graphing calculator, solving it for x, I could simply rewrite this as going to be 4y is equal to 4 minus x squared, divide both sides by 4, divide both sides by 4, and y is equal to 4 minus x squared over 4. For the purposes of the graphing calculator, that is perfectly acceptable. Okay? Now, if you are supposed to go and provide a simplified function, you'd want to go through and do a little bit more work so that you had y was going to be equal to 1 minus 1/4 x squared. But again, depending upon what you're looking for, one is going to be easier than the other. And it really always boils down to what is the expected use of it? What is the output of it? If you're supposed to have and identify slope, well, then you probably better go down to the last one. If you're looking for the intercept, that go down to the last one. If you're just simply looking at putting it into a and looking at its graph and analyzing it, well, then you can just stick with the second one. Again, it's just whatever you need to deal with the problem. So, direct variation. This is something that you probably haven't talked all too much about, but I can tell you this, you already know this instinctively, especially if you go and put gas in a car. That's a direct variation equation. Think about it. Is what you pay, does that vary directly, or does that change directly? Is it directly related to how much gas you put in the car? If you put 5 gallons in the car, it's a heck of a lot cheaper than putting 10 gallons in the car, right? Directly proportional. Every gallon costs a certain amount, correct? Direct variation. So, with that, I will leave you to begin